بسم الله الرحمن الرحيم. إن شاء الله محاضرتنا اليوم راح تكون عن clinical handling of glass ionomers. Glass ionomers are considered smart dental materials. The most important properties of those materials are their ability to release fluoride, which has an important role in teeth remineralization. Since its first introduction in the market by Wilson and Kent, the conventional glass ionomer has undergone many modifications to improve the mechanical, physical, and aesthetic properties without losing the fluoride release. As you see here in this timeline, since its first introduction in 1970s, many modification has happened to this material, starting with the metal modification, resin modification, until today we have the nanotechnology added some resin fillers or some fillers, nanofillers to the conventional resin modified material. However, the data is still, the clinical data is still limited for those new materials, so we will concentrate on 4 major types in our today lecture. There is many uses for the different types of glass ionomers. For example, we have the conventional glass ionomers and resin modified glass ionomers. They are usually used in many applications, starting from fissure sealing, filling, the liner spaces, and also as a cements for indirect restorations. The compomers, they're usually used in treating deciduous teeth. They have limited application in our clinic. However, they are material that is present and you can use it in children. The metal reinforced, it has the color of gray like amalgam. We usually use it as a basis and cores in posterior teeth. The indication for using glass ionomer materials, they are the material of choice to treat root caries and class 5 lesions, and also non-carious lesions like erosion and abrasions, and sometimes we use them in sandwich technique in class 2 restorations where we apply the glass ionomer to the deepest part at the cervical area of the box, and then we restore the remaining of the cavity with other materials like composite or amalgam. However, we have some contraindication for those materials. They are mechanically weak, that's why we can't use them in stress-bearing area, and also they are not aesthetic compared with composite, so we don't use them in anterior region. The advantage of glass ionomers, as we say before, they are a material that release fluoride. However, this depends on the material itself. They bond to enamel and dentine, and this is a chemical bonding to the calcium part of the hydroxyapatite present in enamel and dentine. However, their bond strength is inferior to the bond strength of dentine bonding agent. They place little stresses on tooth structure when sitting because they have coefficient of thermal expansion that is similar to the tooth structure, and finally they buffer acidic condition in their venicity. As we say, they have fluoride. Fluoride is a negative ion. It can react with the H plus proton that come from the acids, and it can buffer this acid because of the fluoride content. Concerning fluoride release, you can see in this graph that conventional glass ionomer has the highest fluoride release, followed by resin modified and metal modified materials, and the least material that releases fluoride is compomers. And actually this is related to the chemical combustion of those materials and the setting reaction for them, and we'll speak about that later on. Now there is some disadvantage of glass ionomers materials. As we said before, aesthetic is inferior to composite, so they are not used in anterior area. The physical properties is they have limited strength and wear resistance, can't be used in a high stress area, and they dehydrate and make a crack on the surface during sitting because they are very sensitive to water uptake. Now let's speak about the chemical formula or the combustion of those materials. The conventional material, which was introduced by Wilson and Kent, it consists of powder and liquid. And you can see on the left side that the liquid consists of aqueous solution of polycarboxylic acid that will react with the powder part, which is a fluoroaluminium silicate glass with high fluoride content. And a recent formula, they have different metals added to this material. Now let's speak about the setting reaction, how those materials set. Uh, as you see in the left side, we have the powder particle in the above, and we have the liquid part below. When we mix them together, we will have decombustion of the powder. The acid particles that have COO minus, they will attack the powder particles, and you can see in this graph that there's H plus ions that will attack the powder. Now when this happens, we will have decombustion of the metals present in the powder. The M ions will be released from this powder part, and this is called migration of metal ions. Now those metal ions, they have positive charge. They will now interact with the different negatively charged acid groups, and they connect them together, and this is called the cross-linking of the different chains. And you can see on the right side of the graph that we have gelation and maturation phase. At this stage, the positively charged ions from the powder will connect many parts or many molecules of the acid that is negatively charged. Now those materials or those ions actually are the calcium and the aluminum that will be responsible for the gelation and maturation. So at the end, this is an acid-base reaction, and the full strength of the material is not achieved directly. It needs time, and usually maturation take up to 6 months until it's completed. And however, after 24 hours, the strength or the maturation is acceptable for the material in the application that we use in the industry. Now let's look at the set material, what we have. As you see in this graph, we have the acid molecules cross-linked together. The acid is represented by COO minus groups, and they are cross-linked by the calcium and the aluminum in the matrix, and of course we have unreacted particle present there. Now look at the fluoride in the blue circle. Fluoride is not entering in the setting reaction. That's why they are free to be released in the vicinity of the restoration. So fluoride doesn't enter in the setting reaction. That's why it's released from the material. And when you apply fluoride to the material using the toothpaste or mouth rinses that has a fluoride, it should be easily entered in those material and recharge the surface of the glass ionomer. Now, what about the adhesion of the conventional glass ionomer to the dot structure? As you see in the picture, dot structure has hydroxyapatite, and hydroxyapatite has calcium and phosphate groups. So there will be polar attraction occur between the cut surfaces through the calcium and the material through the COO minus group coming from the acid. Now this adhesion is weak chemical chelation bond. However, it's predictable, effective, and durable. And bonding between glass ionomer and enamel may be stronger than the bond between enamel prism themselves, especially when they are running parallel to the enamel surface. So this bond is predictable, although it's weak. However, it's still predictable and effective for us for the application that we use those materials in the industry. Now let's speak about the water rule in those materials. Water is very important for those materials because the setting reaction is acid-base reaction. If dehydration or water uptake happen, glass ionomer will be dimensionally unstable. So it's necessary to protect the surface of the newly materials with a thin coat, either of light cured resin or sometimes we use petroleum jelly. because water make more than 24% of the restoration and can be easily removed by dehydration. And you can remember that when we place our restoration, we usually make isolation using the rubber dam, so the tooth is dehydrated. So we need to be careful with application of those materials. We should protect the surface. Also, the calcium polyacrylate that form during the setting reaction and maturation are highly soluble in water, so that further water uptake from the restoration will occur, and this will lead to dehydration. So be careful with those materials. After you place the conventional glass ionomer materials, you need to protect the surface immediately. Now, what about the powder liquid ratio? The powder liquid ratio is very essential for those materials, and they will affect the strength of the material. If you have a high powder liquid ratio, the strength will increase, and if it's low powder liquid ratio, the strength will decrease. If you place the wrong amount of or reduce the powder liquid ratio, you might reduce the strength, you might have poor appearance and questionable dimensional stability. And it's very important to follow the manufacturer instruction for manually mixed material. For example, the powder and liquid material, the instruction will give you for how to mix it for lining, because you need a flowable material for lining application. You need a thicker material for base application or restorative application, and if you use it as a fissure sealant, also you need to use it very thin consistency. It's very important to follow the manufacturer instruction for the purpose that you will use this material. Now let's speak about conditioning the surface. You remember when we speak about composite, we say that we need to clean the surface with phosphoric acid and condition the surface to be able to bond to it. Do we need this with the glass ionomers? During the restoration of teeth where little or no cavity preparation is required, some soft of conditioning or cleaning is required, since the tooth may be covered with a pellicle or other surface debris. So it's advisable to clean the surface. However, we don't need to use a strong acid when we apply glass ionomers, and this is because the strong acid will remove part of the calcium present in the hydroxyapatite. And as we say in the setting reaction, we rely on the calcium to bond to the tooth structure. So if you remove it with the strong acid, you will have a weak bond between the glass ionomer and the structure. So strong acids are contraindicated. You need to condition the dentine with weaker acids, and we will speak about what's the best material now. So weak acid will remove the debris and the smear layer and the pellicle without interfering with the calcium content present in the hydroxyapatite. Now the best material to use as a conditioning is the polyacrylic acid, and this is the material that is present in the glass ionomer liquid part. As we said before, that the liquid part of conventional glass ionomer consists of polyacrylic acid. So polyacrylic acid by itself is a weak acid. You can use it to clean the surface. It has a minor effect on dentine. It just removes the surface contaminant and smear layer without opening the dentinal tubules too wide and protect the calcium content. Also, it's the acid used in the cement itself, so any residue left will not interfere with the bonding, and it will enhance the wettability of the surface and reactive calcium and phosphorus ion, making them more available for the exchange with the cement. So to summarize everything about conventional glass ionomers, we need to know that they are acid-base reaction. They have acid-base reaction, consist of a powder and liquid. The liquid consists of polycarboxylic or polyacrylic acid that react with the aluminum silicate glass powder, and this will lead to release of metals that will connect or cross-link the different molecules of the acid together, making the material hard and mature. We need to condition the tooth, and we usually use polyacrylic acid as a conditioner, and we need to protect the surface after application with either petroleum jelly or resin to prevent water dehydration from the materials. Now, the second modification that happened to this material is the resin modified glass ionomers. Now, those materials developed to overcome the problem of moisture sensitivity and also the low initial mechanical strength typical for conventional glass ionomers. Those materials can come either like a liquid and powder, or sometimes you can use a two-base system like a clicker system, or sometimes they come as one tube that has auto mix step. Now the liquid part of those material, it consists of the polycarboxylic acid. However, there is a supplemented polymerized group. We call it the HEMA or hydrophilic methacrylate group. In a liquid or any other methacrylate group is added to the polyacrylic acid. So the liquid part has the same conventional liquid for glass ionomer and also or supplemented with HEMA parts. And HEMA part has a methacrylated group, which is C double bond C. This will polymerize together to make long chains. So we have both setting reaction of the conventional supplemented by polymerization. The powder part is the same. It's the aluminum silicate glass powder, the same present in the conventional material. Now, this graph shows you the setting reaction. As we say, the same acid-base reaction like the conventional glass ionomer. However, we have HEMA group, and those HEMA group, they will connect to each other, making another chains, and those chains will support the conventional acid-base reaction, make the material more or stronger than the conventional type. Now, about the polymerization reaction, it could be either self-cured polymerization or it could be light cured, depending on the material that you buy from the supplier. About the fluoride release from those materials, they show fluoride release and uptake close to the conventional material. They said the sets of the resin is light activated in the light activated material. However, I say there is some material that are self-activated. The set and maturation of glass ionomer components happen with acid-base reaction, continue after light exposure. So those materials are more user-friendly. Those materials want more user-friendly than conventional material, so you can apply them in the cavity. Then you can start the, for example, light materials, light cured materials, you can use the light, and the reaction will start, the polymerization reaction will start, and the acid-base reaction will continue together with after the light exposure. Those materials, they bond chemically to the resin component in composite, because the HEMA component is usually used in composite itself, so they can interact with the resin or resin part of the composite, so they are the best material in sandwich technique. The one part or the resin modified will bond to the dust structure. So one part of the resin modified glass ionomer will bond to the dot structure via the polar attraction with calcium, and the other part will bond to the resin composite using the HEMA group present in the resin modified glass ionomers. And this is the best for sandwich technique. Now, this material doesn't shrink like composite. The part or the HEMA group the resin part can shrink after setting. However, those materials, as we say, they are supplemented with acid-base reaction. So the acid-base reaction will continually take water from the surrounding, and this water will compensate for any shrinkage happen with the HEMA group present in the material. The color change may occur over time due also to water uptake. They are significantly stronger than the conventional glass ionomers, so usually they are indicated for class 5, class 1 and 2 in primary dentition, and there is some self-adhesion with those material, but more reliable bonding will take place with the use of conditioner or a primer containing HEMA, as you remember when we speak about composite. Now, after initial set as in conventional glass ionomer, there will be some maturation of this material. So there will be some dynamic interaction occur after these materials are initially set. They can be also porous to pulp fluid, and also there will be something called absorption layer formation between the glass ionomer and the dentine. This is related to, again, to the acid-base reaction. Those material will try to take water when they set, and when they are very close to the pulp, they will try to remove the water from the dentine, and that's why we will have something called absorption layer. Usually it's easily stained layer between the bulk of the material and dentine, and this is related to the removal of water from the pulp caused by the acid-base reaction. Now, another modification for the conventional glass ionomer was the metal modified glass ionomers. Those modifications provide a slight increase in wear resistance and radio opacity. This is done by using the amalgam alloy. If you remember the capsule of amalgam that we use in the lab, it has two parts, the mercury liquid and the amalgam alloy, which is the powder. So in this case, we just use the amalgam alloy itself. We don't use the mercury, and we add this material to the powder part of the conventional glass ionomer. The liquid stay the same. So here we have the metal modified glass ionomer. What about the setting reaction? It's exactly the same like the conventional glass ionomer. There is no change in the setting reaction of the metal modified glass ionomer. However, you will have more, or you will have the ions or the metals that are present in the amalgam, the silver, copper, and tin, present or enter in the interaction of those materials. And this link refer you to a small presentation about the metal modified glass ionomer. I hope that everybody will go to this link and watch the video. Now, the last modification we will speak about is the polyacid modified resin composite, or the Compomers. Those materials claim to combine the mechanical and aesthetic properties of composite with the fluoride releasing advantage of conventional glass ionomers. However, we speak about the fluoride release from those materials affected actually by this modification. In those materials, we don't have the polyacrylic resin or the polyacrylic part of the liquid present in the conventional. This was replaced by the same matrix material that are present in composite. So those materials doesn't came as powder liquid, they came as one base system consists of matrix and fillers, and this is exactly like composite. Composite consists of matrix, fillers, and some silane coupling agent. So those materials, they have the matrix as conventional macromolecules, the same present in composite usually, like this GMA, TIG-DMA, UDMA, and they have an acid functional monomer. Like TCB resin, you can see here that this resin has both polycarboxylate group and methacrylate group. The polycarboxylate group, the COO minus, that was present in the liquid in the conventional glass ionomer, and the methacrylate group that make polymerization with other monomers. And the powder part consists of the same ion leachable glass that contain aluminum, silicate, calcium, fluoride, and other material. It's exactly the same powder that is present in conventional glass ionomers. Now, those materials, the compomers, they are usually more tolerant to moisture than conventional composite. However, they are hydrophobic. They are like composite, hydrophobic. So to bond them to the two structure, actually you need an intermediary bonding agent, and they need a hydrophilic bonding system. As you remember, when we speak about the bonding agent for composite, we need a primer, and this primer should be hydrophilic to be able to penetrate inside the hydrophilic dentine. They are significantly stronger than the conventional glass enamelers, so they are indicated for use in class 3 and class 5 restoration in class 1 and 2 in primary teeth. Their application is mainly used in children teeth, in treating children teeth. However, in our practice, we usually don't use those materials because we have the composite, and the composite is more aesthetic than those materials. So at the end, let's summarize what we speak about. We speak about conventional glass ionomer, the first material to be introduced in 1970s, and followed by the resin modified glass ionomer, where we have the same conventional supplemented with a resin component. Then we have the metal modification, where we have amalgam alloy added to the powder part of the material. And finally, we have the compomers, where we replace the liquid part, the aqueous liquid part, with monomers, the same that is used in composite resin. And we keep the powder the same as in conventional glass ionomers. Now, compomers is not considered a glass ionomer material. It's because it's very close to the composite. However, it is still mentioned with the glass ionomers or glass ionomer family. Now let's speak about the important part for us, the clinical technique for using glass ionomer. As we say, glass ionomer can be used as a fissure sealant, as a restorative material, as a liner, as a base, and also for cementation. So first, let's speak about the fissure sealing or fissure sealant material. They are the material of choice for on erupting teeth. They should be considered as temporary measure, and they are effective where resin sealant can't be used because the proper isolation is difficult. And you will take many lectures in pediatric dentistry about those materials, so I will speak about them briefly. The clinical technique for fissure sealant, you need to isolate the tooth, and then you need to clean the tooth with 10% polyacrylic acid for 20 seconds. As we say, this is a conditioner for glass ionomer, and it's better than the strong acid, the phosphoric acid. After we apply the polyacrylic acid, we wash and dry the surface, and then we mix the glass ionomer into flowable consistency according to the manufacturer instruction, and then we apply it along the fissure and burnish it in a place, and excess material should be removed with the burnisher. If you use a conventional glass ionomer, it's self-set material. If you use a resin modified glass ionomer, you need to see if it's a self-cured or you need to apply the light to cure the material. Now, what about the clinical technique for the use of GIC as a restorative material? As you remember, when we speak about cavity preparation, we need to access to the caries, and then we need to remove the caries, and then we will start with the restorative part. We need to dentine conditioning with polyacrylic acid for 10 to 20 seconds. Then we need to wash the acid, dry the tooth, and then we will apply the glass ionomer restoration and make finishing for this restoration. For erosion and abrasion lesions, those lesions doesn't have caries, so usually we don't remove caries in those lesions. However, we need to rough the surface, and we speak about that when we speak about class 5, how to rough the surface. Then we will proceed with the same procedure, dentine conditioning with polyacrylic acid, washing, drying, application, and finally finishing. Now let's speak about the steps as we did in the lab. Everybody did a class 5 glass ionomer in the lab. First, after we prepare the cavity, we condition the surface with polyacrylic acid. If you don't have polyacrylic acid, you can use phosphoric acid, but only for 5 seconds, very fast application. Then you will wash and dry the cavity with water and air. Then after that, the capsule, we told you that we have two different capsules. The one that has the activation button on the side and the other have the activation button at the end of the capsule. So you need to activate the capsule, then you need to mix it in an amalgamator. After that, you will add the capsule to the applicator and then press the applicator many times until the material is expressed from the tip of the capsule. You will fill your cavity with excess material, then you will adapt the material to the cavity and remove the excess with a carver, and or you can use a cervical matrix. After the material set, you will start finishing and polishing the material. Usually we use a blade to remove the excess, and then after the material sets for a while, we will start using the same finishing and polishing discs and stones that we use with composite. We will use them to finish the material. And finally, if we use conventional glass ionomer, we need to protect the surface before the patient leaves the clinic. Now, we use in our clinic and also in the lab the Riva GIC material. So this video is taken from their website. I hope that everybody will see the different steps and different material that they have and how to apply them to the cavity and use them as a restoration. Now, what are the clinical techniques for the use of GIC as a cement material? Inshallah, everybody will use those material next 2 years to cement their crowns and bridges. So first you need to wash and dry the teeth, the prepared teeth. Here you don't need to condition the surface actually. You just clean and dry the teeth with water. Then you will mix your material with the correct powder to liquid ratio according to the manufacturer instruction. Then you will paint your material or apply your cement to the fitting surface of the crown, and you can apply a little bit of the material to the tooth structure, and after that you will insert your crown on the prepared teeth. Wait until the material first initially set, and then you can use your probe to remove the excess amount. After sitting, you can use the floss to remove the excess from interproximal area, and after that you can check that everything is okay and give your instruction to the patient. What about using those material as a liner? The same procedure after you prepare the cavity and you decide that you need to protect the bulb, you need to condition the dentine with polyacrylic acid, wash and dry the cavity. Then you need to mix the glass ionomer according to manufacturer instruction. It should be a little bit flowy or has a flowable consistency. Then you will apply the glass ionomer to the deepest part of the cavity, and you don't need to cover the walls. As you see in those pictures, the material is confined to the deepest part, close to the bulb. There is no material on the walls. If the material comes on the wall, you need to clean it with either a hand instrument or a slow speed round wear to remove any excess from those walls. And after that, you will place your final restoration, either amalgam or composite. Now, if you need to use those material as a base, now the difference between liner and base is the thickness actually. So if we need to use it as a base, we usually use thick consistency, not like a flowable liner consistency. First, we need to condition the dentine and wash and dry. Then we will mix the glass ionomer according to the manufacturer instruction with thick consistency. And actually in this application, I usually use the capsule used for restoration. So this is an easier way. It's better than mixing the material yourself because it's very difficult to make a thick consistency using manual mixing. So the capsule give you a better choice. Then you'll apply the glass ionomer restoration to all the cavity, restore the full contour with the glass ionomer, and using also, of course, a matrix if you use it for a glass tool. And after the material set, we will cut back the glass ionomer to create space for our final restoration. So here you can see in the picture that we cut back the cavity, remove all the glass ionomer from the enamel margin, and we keep the part that is close to the bulb, and we create certain shape or the same shape like class 2 on those spaces. And after that, we will place our final restoration, either amalgam or composite. Finally, we'll speak about some important factors to consider when we apply glass ionomers. First, the mixing of or manual mixing of those materials should be within 25 to 30 seconds to optimize the powder incorporation. Usually capsules are recommended because they optimize and simplify the application. If you use the material for restoration or base, it's better to use the capsule type. Glass ionomer should be applied to the cavity with excess and then shaped quickly with a composite instrument because you don't need it to be underfilled. And clear cervical matrices may be used for contouring the filling. It's the same cervical matrix that we use for composite. However, you need maybe to lubricate it a little bit with petroleum jelly or bonding agent to prevent its stiffness to the surface of the glass ionomer. Now the final finishing of those materials is exactly like composite. You can use finishing burrs, you can use discs, you can use stones, you can use the number 12 surgical blade to remove the excess or overhangs, and then final finishing with the finishing and polishing burrs. Now those are our references. All references are present on our website, so you can refer them whenever you want. I hope that this recording was helpful to understand the material. If you have any question, you can send me an email or send your inquiry through WhatsApp group through your representative. Take care and goodbye.